So we did 2 examples of the square root method yesterday. We'll do a few more here today. The square root method for solving really only works in kind of 2 specific cases. This one here where we have the variable inside of a set of parentheses squared and there's not any other variables outside of it. Or if the variable being squared is the only one we have. We only have x squared, we don't have x. Here we do have that the variable is inside a set of parentheses squared. So just like with yesterday, we want to get it by itself. Yesterday, all the ones we worked with, we wanted to get x squared by itself. Here we want to get that set of parentheses squared by itself. Because if we take the square root of that set of parentheses squared, the square root and the square will simplify out. But we want to get it by itself first. So what can we do? Well, we need to remove the 2/5. We need to get it away from the parentheses. So we can divide both sides by 2/5 or multiply both sides by 5/2. Because we can multiply it by its reciprocal. Because over here, the 5/2 times 2/5, well, on top I have 5 times 2, on bottom I have 2 times 5. Well, that's just going to be 10 over 10, which just simplifies to 1. Anything divided by itself is 1, so it's gone. So what we have left with is x plus 3 squared is equal to because the 5 will multiply with just the numerator, the top of the fraction. And 5 times 5 would give us 25 over 2. Do we have the set of parentheses by itself? Is there anything being multiplied outside the parentheses? Anything being added to it? No, so they're by themselves. So we can go on and square root both sides. Because the square root and the square will cancel out, leaving us with just x plus 3 is equal to plus or minus. Well, now we need to figure out what the square root of 25/2 is. Now, if we plugged it into the graphing calculator, it will give us a decimal number, an irrational number. Now, if we want to plug it into the yellow calculator, we'll need to split it up into the square root of 25 over the square root of 2. And we could type this into the yellow calculator and it would give us the actual answer. Because if we work this out by hand, well, the square root of 25 is over the square root of 2. Now, we can't leave a square root in the denominator. And the real best reason I can see about this is we don't want to leave an irrational number, a non-repeating, non-terminating decimal in the bottom of a fraction. So what we'll do is we'll multiply the top and bottom by the square root of 2. Now the numerator is just going to be 5 square root of 2, because 5 times the square root of 2 is just 5 square root of 2. Now the denominator, we have the square root of 2 times the square root of 2, which I can rewrite as the square root of 2 squared, because anything times itself is being squared. All a square root and square would cancel out, leaving us with 5 square root of 2 over 2. And that's really what we call that is rationalizing the denominator. But again, if we typed it into the yellow calculator as this, it would tell us the exact same thing. Unfortunately, we're not quite done because do we have x by itself? No. So we need to subtract 3 from both sides. Here the 3 and 3 will cancel, telling me x is equal to negative 3. Whatever number we add or subtract, we'll always put it in front of the plus or minus. And then we have plus or minus 5 square root of 2 over 2. And that right there is the answer. Now, if we wanted to, we can convert this over. Negative 3 plus 5 square root of 2 over 2. And it'll tell us that it's, if we take and approximate it out as a decimal, we'll get this here. We could also take the negative case. Which would be negative 6.535533906. If we convert it into a decimal, we need both. But if we leave it as the plus or minus, we have it as there. Questions on this here? Yes, sir.
You don't have plus or minus, so it counted wrong.
Yes, because really what we're saying with the plus or minus is that we have these two answers. So there's two specific answers that we have. Now, here, because of the square root of 2, since it's an irrational number, it's a non-repeating, non-terminating decimal, we can leave it as negative 3 plus or minus 5 square root of 2 over 2. Because we really just can't combine the negative 3 and the 5 square root of 2 over 2. They're not the same number because of that square root of 2. Now, if we'd gotten down to this here and it said negative 3 plus or minus 4, well, I can do negative 3 plus 4 and get a number. I can do negative 3 minus 4 and get a number. If we can add and subtract them, we're going to. But here, because they're not like terms, we can't add and subtract these. We can leave it here. Questions on this here? Now this one here is like one of the ones we did yesterday. Now we can use the square root method because the only variable that we have is x squared. We don't have any other variable x. The only one that we have is the x squared. Even if we did have more than one variable, if we had another x squared on the other side, it still works because the only terms that we have is x squared. We don't have an x term, x to the first. So what can we do first? 20 minus 14 is? What can we do next?
3 over 2 multiplied.
We need to multiply both sides or divide by the 2/3 because we do need the x squared by itself first. So if we multiply, we'd be multiplying by 3 over 2. It's reciprocal because these here will simplify to 1, leaving us with just x squared is equal to 6 divided by 2 is 3. 3 times 3 is, because we could do 6 times 3, which is 18, and then divide by 2. A lot of the times I like doing if we can divide evenly. I'll do that first and simplify down, and then multiply together. Either way works. X squared is by itself, so we would square root both sides, so x is equal to what? Because negative 3 squared, negative 3 times negative 3 is positive 9. 3 times 3 is still positive 9. So we get this here. Could we have solved this here by graphing? Because what did we say graphing worked very well for is if the numbers were a whole number. Is positive negative 3 whole numbers? So could we have solved this by graphing? Yes. Could we have solved this one by graphing? No, because those are non-repeating, non-terminating decimals. That would be very difficult to find. We could approximate it if we asked the calculator, the graphing calculator, to do that. I know we can do this one here, but let's go on and look at this one here, because I want to do one more with our parentheses. So what can we do first? Divide by 2, because that's the only thing that we have with it. So we have x minus 4 squared is equal to negative 5 halves, yes? Our next step would be 2. Different color, square root both sides, yes? Square root of, and the square would cancel, leaving us with equals. So, I mean, we can break it up. Square root of negative 5 over the square root of 2. In the calculator, take the square root of negative 5. We'll see what it says. Actually, non-real. So at this point, we can't find it. Because what we're saying when we take the square root is we want to find a number times itself that gives me that number, yes? So if the number is negative, a negative times a negative would give me a positive times a positive would be a positive as well, yes? Is there any way that I can multiply a number by itself and get a negative? No. So what that tells us here is that this one is no solution. Starting after really tomorrow and Friday, we will actually be able to find the solutions. And they're not as difficult as they might seem. Any other questions on what we've covered so far? Now, the last thing we have is factoring, but I feel like at this point you all feel very solid with factoring because we spent 3 days on this and solving. The one type that I do want to look at with this here is number 9. Is number 9 here. Because finding the solutions or finding the roots or finding the zeros is doing the exact same thing. We're wanting to try to find what value of x will make the function equal 0. That's why we call it the zeros. Now looking at number 9, we're really wanting to find and figure out when x squared minus 8x is equal to 0. And we're going to do it by factoring. So the first thing we would look for is a greatest common factor. Is there something in common with x squared and 8x? Is x in common with both? So we can actually factor it out. X out of x squared would be x. X out of 8x would be 8. Now this here is one of the cases where we can't divide by that x, even though it is a greatest common factor, because each x does give us a solution. So if we divided it out, we would have lost one of the solutions. Now, factoring the x out, do I have two things multiplied together that equal 0? Well, yes. So that means that either here x is equal to, or x minus 8 is equal to, okay. We got one of them already, x equals 0. Add 8 to both sides. And that's it. And that's the only one I really wanted to look at and go over, because we hadn't specifically done that, but that one's not too overly challenging. Questions on any of this here? That's it. That is all we're doing with 3.3. Now, you do have the rest of the time to work on the assignment in class, which might be a good thing because some of them do require you to solve by graphing, just graphing the function and finding the x-intercepts where it crosses the x-axis, or where the y value will be 0. What values of x will make the y value 0? So, I'm going to give you the rest of the time to work on that.